Welcome back to this tutorial. One of the things that I've realized when handling machine learning, it's good to handle some machine learning concepts. For now, I'll be focusing on only decision trees, which is a popular supervised learning algorithm used for both classification and regression tasks. So the decision tree model handles both classification and regression tasks. I've explained this in the previous class. I'll just be using the practical example in real life to deal with decision trees. We will still maintain our dataset for heart disease, and it's the one we are going to train the model for decision trees on it. So make sure that you have this dataset. If you don't have it, I'll leave a link in the description where you can download this dataset from. So here are the things that you need to consider. You need to learn how to split the criteria for decision trees to make decisions at each internal node, and these leaf nodes are the one that will be used for the classification task or for the predicted values in the regression task. We will be able to perform some bit of prediction, recursive splitting, criteria splitting, and these are the things that you need to know about decision trees. Easy to understand and interpret, can handle both categorical and numerical features, can capture non-linear relationship between features, can handle missing values or outliers, and the limitations are prone to overfitting, can be sensitive to small changes, may perform well if there are irrelevant features or noisy data. Decision trees can also be biased toward features which is more level or high in cardinality. So let's see how we can do this practically in real life. We'll just use this same example of this data set here, which I'm hovering over it. So let's start and we be able to move faster. I'll be able to explain all the concepts line by line, and I hope this would be able to help you understand. First, you need to import libraries. So the libraries that you need to import, basically I'll try my best to show you how to deal with this using there are two approaches. I will show it to you. I hope this will help you understand this very well. Let's start by importing NumPy for our numerical Python. Import NumPy as NP. In my previous class, I've explained to you that NumPy is basically for linear algebra. Then let's import pandas. Import pandas as PD, which is basically for data processing, preparation and processing, or data manipulation. Then we can also import if we're going to do some bit of plotting, but basically this is not really necessary. But what is important is to import so what is necessary here is basically to import it's necessary to just import. We have pandas, we have NumPy, so we can import graph this. For for visualization of the leaf node. So sometimes you may not have GraphViz installed on your computer. You go to your terminal, then type pip install GraphViz. I see here requirement already satisfied, means I already have GraphViz installed on my computer. If you don't have that, please just install that on your machine. Okay, next what you could do after importing GraphViz, you can also import from Scikit-learn. Now these are machine learning libraries. Machine learning libraries to help you learn and make predictions. So the machine learning library is Scikit-learn import tree. And then we also have from Scikit-learn dot tree import decision tree classifier, because we are going to use it. I told you that it's used for both classification and regression. Then we can also have from Scikit-learn model selection import model for train and test, which is very important when dealing with the libraries. Now another thing that we would add any library that we need, just in case we fail to or we run into some error. So I think that is already an important thing that we need to do. We've already imported the Scikit-learn tree. We already imported also pandas. Now we need to focus on one thing, which I'll explain to you here. Each and every time I'm dealing with my visualization, I always prefer this is a library for decision tree. I also prefer to have the control of my display. Control display. But this particular part is optional. But I like always controlling my display, especially how my display is supposed to be displayed in my VS Code. The background color, I'll always pick a gray color, and that's my favorite color. We can do pd dot options dot display dot max underscore column equals to 50 and SNS. I haven't imported Seaborn, so I'll be able to go back and import Seaborn for statistical analysis. So let me just add it here. Import seaborn as SNS, which is basically for statistical data visualization. Then I can also import matplotlib as plt. Matplot, this is basically for plotting and data visualization. And sometimes I could use this inline, which is matplotlib inline. Okay, so I hope this will help you. These are the most common libraries I use. So we can have seaborn dot set. The set, we are going to pass in the parameter for style, and the style is going to be, it's going to be dark grid. So the dark grid, and the RC, the row column is going to be, RC is row column, is going to be axis. Don't worry about these parameters because we have already used them before. First color, and then the color is going to be, I want to use this color code 616E7C. You could use color dropper to check this color code, which I normally prefer using it. Now there are these warnings that always disturb. You could just ignore the warning and say import warnings, then warnings dot filter warning, then you pass in the parameter for ignore. Okay, this is what I like doing whenever I want to play around with my data. So I can run this line and I pick the environment, which is the Python kernel that I want to use, 3.10.6, the default one, which comes with the installed operating system. Me, I'm using Linux operating system, though I customize it for Mac, but this shouldn't worry you. Now I can add another cell block. Then from this point, I need to read the data that I'm going to play around with, to do the decision tree with, just for you to understand the data we are dealing with. But otherwise, I would have jumped straight to the model for decision trees. I can now load or read the data set. We've handled this together in class, how to read data set. It shouldn't be difficult. You just need to create a variable for your data frame, and you read, you just do pandas dot read underscore, then you use the quotes and say heart disease dot CSV. Now this is going to be this data set that we are going to read. For us to see the data set, we could just do df.head, and then we pass in, okay, we could leave it with the head method. It will show first 5 rows. So let's run. You can see this is the data that we are going to deal with. The only problem is our target data here. We do not have this other part of, maybe let's show it all to like 10. Now we have some one. If we go 20, you could see. Let's do 20. You see more. So this is going to go up to, we see we have some 20 here, 0, 1. Now in most cases when you're dealing with decision trees or linear regression, you need to set your variable to your target, the target which is going to be the target future, which is going to be the dependent variable, which in most cases we use 0 and 1 to refer. Now in this situation we shall use 0 for not having heart disease and 1 for having heart disease. So that's what we will refer to in this particular. Then our columns, because we've already worked with this, I've already explained this to you. I'm just going to give you a summary of these columns. We already had it in our previous class, so it's the same example we're working with to get the decision tree. CP, chest pain, trace BPS, resting blood pressure, cholesterol, FBPS, fasting blood sugar, just like that. You could check it out. I'm not going to explain because I don't want the video to be too long. Okay, now that we have that, we can now go and try to look at our target value counts. Now let's look at the target value count. We want to know how many people, how many ones are there, how many zeros are there. That is our target value count. So we want to show number of people with heart diseases, with heart disease. So the number of people, we can just look at the column for target. Now in the column for target, we just do df dot target dot value count. So you use the value count. We're not going to pass anything in the parameter, so use the value count method. Then you just run that cell. It will show you that the target contains 1 are 526, 0 is 499. This is the count that we get. This is still simple, shouldn't give you some hard time. Then 2, we want to show percentages of male and female we want to show the percentage of male and female, especially those ones who have the heart diseases. So let's look at it in terms of percentages. Okay, just want to know the percentage of, show percentage of male and female. Now in showing the percentage of male and female, you just need to count underscore, let this come first. So female Then we just want to know the length in that column. The length in the column for df, this is what we can pass in this method for length. df df dot sex. So if it is equivalent to equals to 0, that means that is going to be what? That's going to count for us the number 0 will be female. Then count, we could just copy this code and duplicate it. Then this is going to be male, and the sex 1 is for male. In this case, we can now show the output. Show the output. What we can do, we can just say print. You know, the print is used for displaying. So print, we would have actually said count female, count, we would still get, but it's better to have it display in a more organized way. So I'm going to say percentage of female patient. So we're just looking at percentage of female patient. Now we'll just put a colon to separate that text with our calculated values, which we will put it within the object, and the best is just to put also another colon dot to f. Then we can put the percentage symbol after. Don't worry about it so much about this, but I'll show you. We can format. That means this is where we can do the we can perform some operator function. So we can count female, then divide by the length of what is in sex, then sex, okay. Then what we can do, then you can multiply by 100. Okay, so hopefully this would be okay. So format, if there are no errors, this should be able to return. Let me check it out. Okay, percentage of female, percentage of female 30%. Okay, I think there's something small which I'm going to fix for this line of code to be better. Let's try to organize it a bit. This is going to be percentage of female patient, which we use 2, comma, okay, but format, I'm just double checking, then count female, divide, okay, this is where it gets off from. Let's now try it one more time. Okay, So perfect. Now we can copy this and reuse the code for male. So we've said female here, this is going to be male, and here we're going to also to change it to male. So when you run, that's going to be percentage of male. Our calculations are still okay. That means we now know the percentage of female patients, and we also know the percentage of male patients. Okay, let's now move to, today I'm not going to normalize my data, just to make it much easier for you, not to cram the codes. So I'm going to show the mean. In most cases, if you want to show the mean, you can just say df dot group by, then you refer to the column for target. Target dot mean. All right. So what you can do, you can run this to show you the mean. So these are all the mean for age, sex, in that order, up to our target. Okay. Now let's move to the next thing. We can check for null values. There are so many ways I've shown you in the code. You could use any. I will make it simple today. Show null or none values. You just do df dot is null, then dot sum. You don't pass in anything in this method for summation. Then what you do, just run. It will show you all, there are no null values, which is a good thing. Next, and they're all integers. Okay. Now the next bit of it is, we really don't need it so much for the logistic regression, but let's just have this. Probably you can check the shape after the split and training. Okay, so let's have that. Here is what we're going to do. So let's try as much as possible now to get the ML for training and testing. ML for train and test. Train and test our data. What we can do, we can first create logistic regression for that. You can create logistic regression for that. So we can have our y, which is going to be a variable to store a df target dot our dependent variable dot target dot value. Its values, then I would have looked at only particular columns, but I don't like doing that. So this in one way would also help normalize our data. So we can now do the x data to pick up all the data frame for independent variables in our columns. So we can have only one column, one dependent column, and several independent columns. So we can do that by say x data equals to, then we can do df dot drop. This is just basically to help normalize our data. Which column are we making it normalize? So we want only to pick the target data, the target column to be want only the target column to be our dependent variable. So we can now make that axis 1, so that it is now the only dependent column. No errors, no problems, so we can run this. The next thing that we can do is to check using the split. We can now try to make sure that we split our model for testing, some percentage for testing, some percentage for training. I talked about this. So let's do split for split the data for testing and for training and testing. Let's begin with training and testing. Now, what percentage can you put? I don't want people to be very static. I know in class I talked about 20%, 80%, but you could pick any percentage. For training, I'll be a little bit unique here. I'll pick 67, and for testing, I'll pick 33%. Hope this would give us a more accurate data. Now, we can now, because I've already imported the import model selection, but if you have not, you could repeat it, but it's not necessary to repeat this Scikit-learn, but the only thing is that you have to rerun all the code. So Scikit-learn dot model underscore selection import train test split. This is basically for splitting our data for training and testing. Okay, how do you go about this? I explained to you that the independent variable, most people like using the capital X for it. X train. We want to store X train, X test, Y train, Y test. Okay. Then test. Okay. I think it's maybe test split. Then, since we have all our data here, which we drop to normalize, we can just take the parameter for X data to take our independent variable. Then we take the Y, which is going to be our dependent variable. Okay. Then we can get the test size. Then we can pick 33 is 0.33, 0.33, 0.33. Then we talked about the random size, which is used, the random state, which is used for reproducibility of the, you reproduce it. So which we can this time round try to pick a larger one, like not 0 but 42. Okay, so let's run it, and we can now create another code so that we can see the shape of the data that we are remaining with for training and testing. So let's check check shape of data for remaining after splitting for training and testing. Okay, how are you going to check that? You just do x underscore train dot shape, you put comma, then you pass in another x test dot shape. You run this, it shows you that we have the data which is remaining is now 686, and the one which is for testing is 339, with the 13 data which we are using for training, for testing I mean. So the testing data is that, this is the testing data. On how many columns? These are on 13 columns that we are going to use for testing, to use our decision trees on it. But that's not so much complex. Let's now try to check the data type. Check the data type. No, not database, but data type. So the data type can be x underscore train dot d types. So when you run, it will show you that the only thing is that we have the old peak, which is a floating number, but I don't think this will affect our next line of code. Now let's just try to check to see those old peak. Probably let's just check those x. Check x train header. Checking the x train header, we do x underscore train dot head, the head method. We run that, so we see all these are integer, but when you come to all peak, they are floating. Okay, I've tried to use this data set, so let's just hope nothing will now affect this. So we had already imported the decision trees. What we could do, we could create a model. We could just basically create modules here for decision trees, which we can pass in some parameters for it. Let's see how we can do that. We could do CLF, which is just a variable. Don't strain your mind so much, but I'm just going to use this word Genie, just a variable for decision tree classifier. Now here I'm going to pass in my parameter for criterion to be Guinea. Don't worry about it, I'll explain this. Okay, and then max depth to 3, and random state to 0 to randomize our data. Then, and you don't need to cram this. This can be any variable, can be modules. You will see it anyway. I'll try to change it in the next. So you could have this decision tree, Gini dot. We try to fit our module. Fit. Then what you can do here, you can just do X train and Y train. All I expect here is just to show you that this is just the classifier that we are going to use, and this is the decision tree classifier that we will use. Basically nothing much. Even if you don't write it, it's okay. Then now let's try to look at the predict bit of it, so that we can see what are we predicting. Normally we shall have an array of 1 and 0 from our target data. So let's try to see this using let's try to predict the class label for the test data using the decision tree classifier. Now you could just use Y just for predict, for predict underscore Guinea, and CF Guinea to our variable which we created, then dot predict, then we pass in what? The X test. Okay, then we can just try to get to know the accuracy of the model when we calculate. So what can we do to get to know the accuracy of the model? You could just write another code. No, just basically print to display the output. Print, you basically print, then you do module, this is just a text that you're passing into the parameter test. Model accuracy, model accuracy score with criterion Guinea index. Okay, so you just want to get to know that accuracy. So let's do some bit of simple calculation here using the operand. So we can use the 0.4 f. We're not going to show it in percentage. We're just going to just get the model accuracy. Then we can format. Then we can get accuracy. Accuracy score, which can be Y test, then predict Guinea. Okay, so we can try to close the bracket. Now the only problem here we have is that the accuracy score. What's the problem? Accuracy score is not defined. Since the accuracy score is not defined, I can help you fix this. We can just define from Scikit-learn dot matrices import accuracy score. Yeah, that fixed that problem. Not a problem anyway. So it shows us the accuracy score 0 point and shows all the place values for that, which is a good thing. But what if you just change this and put a dot? It will now try to reduce the decimal point values. Okay, this is the model accuracy which of our Gini index, which is 0.8. Now we've not yet started on the decision tree, but I think we can try to predict the classes here. Let's try to do prediction here. Predict the class label for training data using decision tree classifier. Okay, just use the y, we have it there, y underscore predict Gini. Oh, let's make it a little bit unique. Y, let's create another variable for that. Train to CLF Gini dot predict. Okay, so can use the predict method. Then we pass in a parameter for x train. You may wonder why we pass in that parameter, because we just want to look at the arrays of those parameters that we have. So we can just do y predict. It should be y train, not y test. That's why it's complaining. When you load this, could see this array of our training. So this is just the output which is truncated to help us see those elements which are there. Now let's try to go to the actual work to see these modules. We are almost getting to finish this first part of visualization, since we have now seen our module, how it is performing. Let's just try to print the training set of accuracy score. Okay, how can we do this? We can just do print, then we pass into a parameter of training set accuracy score. Okay, of that would be 0:0.48. CLF. Don't worry about this, I'll explain much more about it. Dot format. You can do CF Guinea dot score. Then in the score we can pass in the parameter for X train and Y train. Okay, then that will just basically print for us the first accuracy of our module. Maybe we can have it to get for us also for testing. I can now just duplicate this code to print for, this is going to be training and testing. Here I'll change it to test, and this is also going to be for test. Then this side of calling it training, this is going to be testing. So we can now try to see the accuracy scores for training and testing. Hope this is okay. We print. So for training is 0.8630, for testing is 0.8112. So our testing set accuracy. Okay, this is not bad. Now let's try to do visualization of our decision trees. I'll show you two ways how to do it. Let me use the first way. So the first way is to visualize the decision tree leaf node. So we will see the child, each branch is going to have two divisions. So let's see how we can do that. There is PLT, which is for plotting, then figure. So figure, figure. Now what we need here is just the figure size, fig size, to take in the height of 12 and no, the width 12, height. So visualize width 12, height 8. So this is basically for create figure for width and height. This is what the first line of code will do. Okay, next, from Scikit-learn we need to import trees. From Scikit-learn we need to import tree. Then let's try to plot this using the traditional way. It will show you a text way of visualizing the data. So we can do tree dot plot tree, then CLF Guinea dot fit X train and Y train. So this should give us the decision tree visualization. Let's try to run this. Wow, so nice that we managed to get this tree node. Each tree contains two branch, two child, one child and one child. Each tree contains one child and one child. So this is how you could do visualization, but I don't like this way of doing it like this. Doesn't look so nice. Let me try to show you another way. Let me show you the next way, how I normally would visualize this. So this is how you could represent some of this decision tree. So let's see how we can do this. There's another way, but first you need to import the graphics. Then there's something that I need you to do. You need to come here and extension and install dot. Install this. Make sure you have this graphics dot language support for Visual Studio Code by João Pinto. It's the one that works. This other one by graphics doesn't work. So make sure you have this extension installed. I already have it installed. Okay. Now what you can do next is to make sure to import graphics for this visualization. Now also import pandas. We already have pandas, but of course make sure you rerun. That means you have to rerun all this all this code, otherwise it may not work. We just have to rerun it all. Here, click on rerun. So I'm just going to get the graphics, the rest. But okay, maybe for you to understand, so visualization, of decision tree. So import graphics, then also import, but this code of block is going to be independent to do all this visualization. The other one I just wanted to show you that with decision tree can help you do classification and regression. That's why I was doing a little bit of regression and classification. Now let's see how we can now import. We already imported panda. It's not necessary, but let's just do it because we will just run only this cell. You may ask me why am I repeating this, yet I've already typed there. You only need to import pandas once. But I said alternatively, even we have loaded our data set, but let's make sure just okay. Let's make sure that we show. Maybe you would use only this particular code for your visualization of the addition tree. So you can import pandas as PD, then import Scikit-learn, import tree. Okay. Oh. So, okay. I think this should have been what? From then that's solve. Then from Scikit-learn underscore model select import train test split. Okay, then you have pandas. You don't need to repeat that again. Import tree, import. Okay, so we have that. So next we can now try to first, we already loaded the data set, so load data set. Just basically we are running only this cell, that's why I'm repeating this, but it wasn't necessary. You could just click here and run everything. So import data, and what next can we do is to read the data. So let's have a different data name, like hat underscore data p.d read CSV, which is going to be our 8 data CSV. Okay, that is for reading. Then you can try to create do some random. We do normalize our data so that we can have the only one dependent variable for what? For testing, and the other dependent variable for testing and training. So we can do y, which is normally used basically for testing. Then we can hat data. Then we can look at the column for target. We know that column because we already looked at it. So this is the column we're looking at. This column here, target. Okay. Then, just like I said, decision tree is the easiest to learn, so I hope it will be easier. But tomorrow I'll upload another video for regression, logistic regression. So we can also have import target. Then we set that axis to 1. Okay, we just need to open the bracket here as well. Okay, then for our X data, we want to take all the columns for our data so that our model can be very accurate. Our decision tree can be accurate for us to make the decision into the leaf nodes. So we can have at dot drop just to normalize. Then target, the parameter we can pass is target. Okay, then axis to 1. The target, this should just be to what? To dot values, because they're normally values, so we don't need to put it in bracket. Okay, so that is much better. Then we can now train the decision tree classifiers, so which we can use model, can create a model for it, model which is going to be tree dot decision tree classifier. we don't pass anything into that decision tree classifier. Then you can now fit our model.fit, which the other time I was using Guinea. I hope now you won't get confused. Then you can get our X data here. Pass in, to fit the model, can pass in our X data. Then we can also pass in the Y data to fit. We have fitted the model. Now we can now get the class name from the data set, which we can call it class underscore name hat underscore data then you can do target into that parameter dot unique as a method, then as type string. We're not doing it as an integer. The as type would be str string. Okay, that is okay. Then we could now try to generate some. Let's generate the target. Let's generate the graphics. The graph visualization. You could do this by writing this small line of code and say tree dot export graphics, to export the graphic into a textual format, which is going to be model. It's what you can pass into our parameter for exporting graph. Then our output will not be to none. The output is going to be the file name in that directory. So the output can be hat underscore column, no, hat disease 1 dot o dot. So this is just going to export a dot file, which is going to be a textual data. Then you could also feature names, which is going to be from the X data dot columns. Then we can also have the class name to class name. We created some class name. Then label, don't worry about these parameters. We will explain this. Okay. Then you could put field to true and rounded to true. All right. So when you run this cell in Ubuntu, which just Control Enter, but you can just click here to run. You realize it's going to generate another file. Okay, we have some error here. which is saying that model pandas has no attribute read. How did we miss that? Okay, I've seen where the problem is. This should be read underscore. So when we run, you realize this is the file it generated, hat underscore 1.odt. So that is the file. Alternatively, you can even generate another file. Instead of calling it what, we can call it neo, and run. It will still generate another file neo here. So now what we need to do, we need to open this. So we've just opened this file here, which is a textual graphical representation of our data. But remember, I explained to you that when you go to extension and install dot by this Jao Pinto, you can visualize this data. So you just come here to click on these three dots, then open preview to the side. Now I could close this and also try to extend this here. It looks big, but this is the best way to do. The CP, if less than that, visualize, comes this, or I can try to fit here. So this is the decision tree that it can generate. It's very good for making decision trees. So you could do this for scaling it up. Okay, so basically this is how you represent decision trees using what can represent your decision trees. So if you watch this video up to this point, please give it a like. If you have any problem probably installing the extensions, running this, leave a comment. I'll get back to you, but I'll share this code onto my GitHub repository. Thank you for watching the video. Tomorrow I'll be uploading another video on logistic regression. I'll cover all my machine learning modules in this platform, particularly in this area, on this Jeff Geoff masterclass. If you have a problem, comment down below. I'll look through the problem and see if I can help you, which I'll get to help you definitely. Thank you. Catch you on another episode tomorrow. I'll upload the episode at 5 p.m. Have a nice day.